Hey guys, welcome back. So in the previous video, we saw how to insert a new node in a single linked list. Hope the concept was clear. Now in this video, let's see how does the algorithm of a insertion of a new node in a single linked list looks like. So the name of the method is insert in linked list. It takes as an argument head reference, the node value that we want to insert in the new node, and the location where we want to insert the new node. So first what we have to do is create a blank node and update the value of that node with the value as given by user. So let's say this is our blank node which is residing at address 666. We update the value part of it with the value given by user, which is 5. Now the next step is we check that if the linked list does not exist. In that case, we return an error. Why? Because if there is no linked list, we cannot insert a new node in it. So in that case, we have to first create a blank linked list, as we have seen in the last video, and then we have to come and insert a new node. So if the linked list exists, then we come to this else condition. What is this condition? This condition is insertion at the first position. So in the else statement we say if location equals 0. That means if you want to insert the node at the 0th location, then we have to do these two steps. That is node.next is equal to head. So what is node right now? Node is this new node which we have created. So node.next is equal to head. Now what is the value of head? Value of head is 001. So we have to insert the value 001 in node.next, which is here 001. So as soon as we insert 001 here, a link gets created between this node and node 1. Now the next step is we have to point the head and this new node and cancel this link. So how to do that? We have to update the head from 001 to 666. So as soon as we do that, a link gets created between head and this node, and the link between head and node 1 gets deleted. So this is how we successfully inserted a new node at the first location. Fine. Now let's say if we want to insert the new node at last position. In that case, we come to this else condition. So the condition says that if location equals last, then all that we have to do is node.next is equal to null. So let's say this node 7 is the node that we want to insert at the last position. So what we have to do is node.next is equal to null. So we put a null value over here, which indicates that there are no more nodes after this node. Now what is the next step? Tail.next is equal to node. Now what is tail.next? So tail.next is basically this reference over here. Now why is that? Because tail is pointing to node 6 and next has null value in it. So all that we want to do here now is we have to update this value from null to the node 7's address. Let's say node 7 address is 777. So as soon as we update the next of node 6, it automatically creates a reference from node 6 to node 7. Now the last step is we have to update the tail reference to point to node. So tail right now points to 555, which is node 6. So now we have to update this value from 555 to 777, because 777 is now the last node in this list. So as soon as we do that, tail starts now pointing to node 7, which is the last node, and this connection over here gets disconnected. So this is how we successfully insert a new node at the last of a linked list. Now let's say if we want to insert a new node at any other position apart from first and last, that is anywhere in middle of the linked list. In that case, the control goes in this block. That is, first we have to create a loop starting from 0, which is the first node, goes till location -1. Now what is location? Let's say we want to insert a new node over here between 3 and 4, which is location 3. So I am assuming that node 1 is location 0, this is location 1, this is location 2, and the new node which will be inserted here will be at location 3. Now you can always start counting from 1 instead of 0, that is up to you. I typically like to count it from 0 so that the counting remains similar to how we do it in array, because in an array we always start with 0. Fine. So what we are doing here is we are looping from 0 to location -1. So the loop first starts from node 1, it goes to node 2, then it goes to node 3 and stops there, because this is location -1. So we have a temporary variable called tmp node. Now this variable over here stores the reference of node 3, which is 222. Now to insert a new node, we repeat the same steps. That is, first we create a blank node and update its value. So let's say the new node is node 7 located at physical address 777. So we have updated the value part of it with 70. Now let's see how we can insert this new node at this location 3. So the first step is node.next is equal to tmp node.next. So what is node.next right now? We are talking about this area over here. So here we need to insert temp node.next. What is temp node.next? Temp node is having value 222. So the temp node.next is basically having a value 333. So what we have to do is we have to insert this 333 over here. So as soon as we insert a 333 value, a link gets created between node 7 and node 4. Now the next step that we have to do is we have to update temp node.next. So what is temp node.next? We are talking about this 333 over here. So we have to update this thing and insert the address of node 7. So as soon as we insert a reference of node 7, a link gets created from node 3 to node 7. So this is how we have successfully insert a new node in between two nodes. So now let's quickly recap this thing. So what we have done is, first we created a blank node called node 7. We inserted a value 70 in it. The address of node 7 is, let's say, 777. Then we created a loop starting from first node and went till location -1, which is node 3. And then we updated node's reference variable and the previous node's reference variable. That is all that we have done. So I hope you have understood how the algorithm looks like. Now let's see what is the time and space complexity of this algorithm. So the time and space complexity is extremely simple. So first we are creating a blank node, which is a constant time operation, inserting a value as a constant time operation, checking if the linked list is existing or not is a constant time operation, and then checking if the location is 0 or not is a constant time operation. Updating the reference of a node is a constant time operation. Updating head reference is a constant time operation. Checking of an else statement is a constant time operation. Updating some of the reference variables is again constant time operation. Else statement is a constant time operation. Looping from 0 till location 1. This is gonna take order of n time. And the reason is that in the worst case, we might have to travel till the second last element in the list. In that case, we have to travel n minus 1 nodes. So the complexity becomes order of n. And then we are updating reference variables. Those are again constant time operations. So the total time complexity for insertion becomes order of n. And the reason is this statement over here. The space complexity is order of 1 because all that we are doing is creating a blank node and creating a temporary variable over here. Nothing more than that. So that is a constant complexity operation. So with that we come to end of this subtopic, that is insertion of a node in a single linked list. In the next video, let's talk about how we can traverse a given linked list. So that's all for this video. Thanks for your time. See you in the next video.